Think of the biggest number you possibly can. Maybe a billion, a trillion, quadrillion, or even more. But I can just add 1 and get an even bigger number. So does that mean that there's no limit? Well, I wouldn't be making this video if there wasn't a limit, so yes, there is a biggest number. This number is called Graham's number, formulated by Ronald Graham in 1971. Before we get into the actual number, let's clarify some notation. What does it mean for a number to have a power? Well, it just means that this base is multiplied by itself x number of times. For example, 3 to the power of 2 just means that it's 3 times 3. 3 multiplied by itself 2 times. This just equals 9. This is pretty simple. But this can take up too much space, especially if you're writing what's called as a power tower. This is why we can use something called as Newton's arrow. This is just a vertical arrow pointing upwards. If you write 3 up arrow 3, this is just the same thing as 3 to the power of 3, or 3 times 3 times 3. This is equal to 27. Now we can do a similar thing by using 2 arrows. So 3 up arrow 3, which is just equal to 3 to the power of 3 to the power of 3. This is a power tower consisting of 3 3s. Similarly, we can do the same thing with 3 followed by 4 up arrows. This is a power tower consisting of 5 3s. We can call this G1. This is already some unimaginably large number. Now let's create a different equation called G2. This consists of 3 followed by a G1 number of arrows. Not 4, not 5, but this many number of arrows. The number of arrows itself is astronomically large, and 3 is being multiplied by itself that many times. But we are not done yet. Now we can keep going with G3, which consists of a G2 number of arrows. We can keep doing this until we reach G64. Yes, you heard me, G64. This is called Graham's number. This number is so large that even trying to comprehend it will turn your brain into a black hole. Now, why did Graham stop at G64? And why did he use 3? Well, it's because of a field of mathematics called Ramsey theory. This studies when structures are guaranteed to appear. This is not completely relevant to this video, and I will be making a future video on it. But what Graham was dealing with was a problem involving high-dimensional hypercubes. Imagine a 3D cube. It has 8 corners. Now imagine a cube of higher dimension than us, for example 4D. Now I know that isn't really possible, but just know that that cube will have more corners than the 3D one. Graham's problem was if you draw lines connecting every pair of corners and color each line one of 2 colors. That is a confusing question, and of course I will make a future video on this, but Graham proved that a guaranteed answer does exist, meaning that there's a number of dimensions where this has to happen. But he needed to put a cap on how big that number of dimensions can be, which is Graham's number. Graham's number is a strange intersection between a real question with a finite answer, and yet so far out of human intuition, it feels like it shouldn't exist. So please don't try to make sense of this number, or else your mind will turn into a black hole.